Alright guys, welcome to the video. Next question here is, we have 6 red, 8 green and 7 blue balls or chocolates. Select 11 chocolates. Right? So how there is now we can do this with little bit faster tricks. So we have x for this we have what, x0 1 to x to power 6, like that. So from the GP geometric progression we can do like this: 1 minus x to power 7 upon 1 minus x into 1 minus x to power 9 upon 1 minus x into 1 minus x to power 8 upon 1 minus x. Right? So now what we can do is, this is what, 1 upon x to power 1 minus x to power 3, and this all is what we can multiply this: 1 minus x to power 7 minus x to power 9 minus x to power 16 and 1 minus x to power 8, like this. For this we are doing what, we know the formula: n minus 1 plus r cr equivalent to 1 minus x to power n. So this is n is 3 here. 3 minus 1 plus r cr and x to power r also, x to power r, right? And this is what, 1 minus x to power 7 minus x to power 9 minus x to power 16. This is greater than 11, so this is discarded also, and this is discarded, so we will not consider it here. Alright, so this is what, minus minus right. So minus here, and x to power 8 plus x to power 15 plus x to power, what is this, 9 8 70. So these all are discarded, which are greater than 11. So we have to select the coefficient: 2 minus r plus rcr x to power r. You have to select the value of r like that. It, after multiplication, it gives the value 11 altogether, right? So for this we have to select 11 only. 13c11 x to power 11 minus, for this we have to select r to value 4, 6c4 x to power 4, 11 I think, yes 11 only, and minus, for this 4c2 x to power 11 minus 3 5c2 x to power 11. So x to power 11 will be take common. 13c2 is like 13 into 6, 78, minus this is like 62, 5 3 15 minus 4c2. 4c2 is like 4 2 3 6. Is it like 2 and 2 4, 4 into 3, this is not 6, this is 3 only. 3 minus 5c2 is like 5 into 4, 5 to 10, like that, 10 15 to 18, 28, 28 minus 50 is the answer, 50, and x power 11. 50 is the coefficient. This is the answer only. It was not 3, it was 6 only. So it is 50, not 50, it is 47. Right, hope you understand this. Right. So we will do some more questions based on this. So let's discuss some more questions here. Next question is this white is why not white working clearly. Hmm? So discard the white and select some different color. Yellow is good. Is it yellow good or not? Red light. Is this good? BM and this is good color only. Right. So question is 3. This is lagging. Identical dice are, why it is lagging so much? Huh? Why is this lagging? Hmm. Right. 3 identical dice are tossed. So how many ways to get some of these outcomes as 12? How many ways to get some of these outcomes as 12? This is the question. So let's do this, guys. How can we do this? Is we have 3 identical dice for x1, this second, and 3. These outcomes should be 12. Right? Distribution of numbers in identical boxes. This is like that. So what we are doing here, x1, what is this? 1 to 6, x1 or x2 or x3. So we have to eliminate the lower constraint. So what we can do is, how can we eliminate lower constraint? It is x1 plus x2 plus x3 minus 12 minus 3 is 9. Right? So now it becomes 0 to 6, 0 to 6 and 0 to 6. Right? Right. So we have to eliminate, uh, now it can 0 to 5 only. 0 to 5, 0 to 5. It cannot get 6. Alright? Oh, but how? Oh, it's 5. don't know, guys, how to do this. Try to wait a minute. But wait, when we do this here, how can we do this? Alright, guys, so what we are doing here is so can we explain with chat GPT here? Can I ask? So we can ask the question. Question should be asked if we are not understanding. Question should be asked. So let's do this, guys. Right. What is the question? Three identical dice are tossed. How many ways to get some of their outcomes as 12? When we solve this question with written functions with equation x1 plus x2 plus x3 equal to 12. Here constraints of random variable x1, x2, x3 are 1 less than 2xi less than 6. 6. But when we eliminate the over constraint from random variables, now equation is x1 plus x2 plus x3 equal to 9, and but constraints become 0, equal to sorry 5 0 0 less than equal to sorry less than equal to 6. Why? This is the problem. A very big problem, I think. So let's understand this. Only problem was sum of 12. We want to find number of ways to get the sum of 12 when three identical dice are solved, right? We can represent this as a x1, x2, x3 is equal to 12, where xi represents the outcome of the ith dice, right? Die. Right? Constraints are 1 is less than equal to xi is less than equal to 6 for each I. Alright. Generative function approach. We can use generative function to solve this problem. Let az be the generative function for the number of ways to get sum of n using the three dice. Basically, we have az z plus z square z3 plus z4 plus z5 z6. Alright. Lead to the lower constraints. Now let's consider the case where there is no lower constraint. Is that 0 is equal to less than equal to 5. We modify the equation x1 to x2 x3 to 9. Since 12 minus 3 is 9, alright. The generative function becomes a1 plus z 5 only. Why this 5 only? When we eliminate the lower constraint, we allow xi to take the value 0, which was not allowed previously, alright. Since the dice outcomes range from 1 to 6, we subtract 1 from each value to get the new range 0 to 5. Alright. Hence the constant becomes final answer. So, alright, this is what we are doing here. This is what we are doing here is. So let's discuss this. Where is the pen? So here subtract 1 from each xi outcome to allow 0 is outcome. 1 of the outcome. Right? This is how it is. And x0 x2 plus x3 4 plus x5 like this. Return function for x1 x1. Right. So yes, alright guys, so this is how we do it, and get the new range. Right, bro. This is not a constructive way to do. Right, this is like that. Now xi 0 to 5. This is the new range for all. And for elaboration, we can do what? For x1, what is the new for generative function for x1 is x0 uh, plus x1 plus dot dot plus x5 for x0, all of them was one generative function for all of them, right? Generative function for whole question will be like this: 1 minus x to power 6 upon 1 minus x into 1 minus x to power 6 upon 1 minus x and 1 minus x to power 6 upon 1 minus x. This will leads us to 1 upon 1 minus x to power 3 to 1 minus x to power 6 into 1 minus x to power 6 into 1 minus x to power 6, right? So how can we do this is outcome should be 9 now, right? So coefficient should be 9. 1 minus x to power 3 and now 1 minus x to power 6 minus x to power 6 minus 12, right? Now this again minus x to power 6 minus x plus x to power 12 plus or 12 plus 12 x to power 18. These all are discarded here and it will become 2 plus r c r x to power r 1 minus x to power 3 x to power 6 like this. And now it can become what to choose for 9 9 11 c 9 x to power 9 minus 3 into 3 5 c 3 x to power 9, right? 11 c 9 11 c 2 5 11 5 55 55 minus 3 5 3 5 3 2 5 2 5 2 5 into 4 are 4 5 to 10 3 30 30. Answer is 25. 25 into x to power 9 is answer and coefficient is 25 is the main answer. All right, next question would be for us is next question is like this: 5 hours 8 blue and 7 green identical chocolates. How many ways to pick 10 chocolates if at least 2 are constants are r is at least 2 means greater than equal to 2 and 1 b greater than is b is what 1. Chocolate must be uh, selected, must be. Why is lagging so much? So much lag. It's, why I don't allow? I have to block this. Right. Next question is this. So what we are doing is x blue plus x red plus x green should be equal to how many select? 10. Should be equal to 10. But the constant is here is greater than red is greater than 2 and blue is greater than equal to 1. So eliminate the lower constraints. It has no upper constraint, so it can be xb plus right xr plus xg is 1 2 3 was 7, right? 7 now, but upper constraint here is now 1 minus from these chocolates also, because these are already selected. Now red are 3 chocolates, 3 are, and we have blue 8 8 not 8 7 blue chocolates and 7 green chocolates. All right, this is the case now. This is a constraint now. All right, it can be 0 and so on. So the same process we will discuss. This is 3 4 1 minus x to power 4 for red upon 1 minus x into 1 minus x to power 8 upon 1 minus x and 1. Why is it lagging so much? This is lagging so much. 1 minus x to power 8 upon 1 minus x. Let it will become direct. We can do this, all right? So 2 plus RCR x to power r. And this is 1 minus x to power 4 minus x to power 8. 12 should be discarded here. And now next is 1 minus this is all and minus x to power 8. X to power 8, all these should be discarded, alright? All x to power, only needed 1 to x to power 4 only. Right, this is already. So we have mixed 7, so 7 for 7 we have 9c7 x to power 7 minus for this 3 5c3 x to power 7. 9c2 minus 5c2, alright, is equal to 98494 ja 36 minus 5c2 is about 5 into 4, right? 4 2 5 10, this 10 26 is the answer. Now this can be done with multiple things. Alright, thank you so much guys. In next lecture we will discuss distribution problems, alright, in combination. So hope you will understand those also. Let me see. Then after that we will discuss a principle of inclusion and exclusion, and then we will discuss derangement laws and some variations. Then we will discuss pigeonhole principle, advanced pigeonhole principle, and so then we will discuss binomial, multinomial summations. Alright. After generating functions, after the generating function we will discuss, and after generating functions we will discuss some recurrence relations. So this is combinatorial recurrence relations, and after that our combinatorics will be finished, or we can complete it. And this it will take few days, and but we will make sure it will just few days. Right? Thank you so much guys for watching the video with me and discussing the lectures. We will meet you in the next one.